For target 10D on the formative, question 11 asks you to categorize each situation to go with the appropriate calculator function. So I just wrote a little note over here about what each function does. So normal CDF is when we have either data, like in a word problem, or z-scores, and we're trying to find probability or area under the curve. They are the same thing. Inverse norm is if you're given probability or area under the curve and you're trying to find data or z-scores. So inverse norm is the inverse of normal CDF. They kind of go backwards of each other. Z-score formula is not when we're going to draw a curve. It's just when it's asking you to find a z-score, but it just gives you a data point and the mean or standard deviation. So when we read through these, this one gives me an average height and a standard deviation, but it asks me to find a percentage. So that's a probability. So that is going to be inverse norm because I'm finding data points. Okay, so like a maximum and a minimum data point given probability. Category 2 says situation 2 says find the z-score for a student's exam that where they scored this and the average is this and the standard deviation is this. So that I'm just going to use the z-score formula. This one says find the z-score, but it's different than the one above because here I'm just saying that represents the lowest 10% of the data. This will require me to draw a curve. I'm given a probability and I'm trying to find a z-score. So that is inverse norm. And then the last one gives me a word problem and it gives me the mean and the standard deviation. And then it says find the probability that something is less than 6 feet. So that is going to be given data, z-scores, mean, standard deviation, find probability. So that is going to be just using normal CDF. So now let's do some problems that are related to this. So for this first one, we're trying to find z-scores. Before I even read it, I'm saying, what am I looking for? I'm looking for a z-score and a z-score and who does better. Remember, finding z-scores is a way to basically compare apples to oranges. So it says fast forward a year and best buds Ryan and Jake are now freshmen in college, but they don't even go to the same school. They're in different classes. So they're trying to compare their scores and their college professors have crazy totals. Okay, so they're not out of 100%. So that's something also to look at. Oh, sorry about that. They're not out of 100%. So we're just going to find the z-scores for each one. So remember the z-score formula is that you take your data and then you subtract the mean and you divide by the standard deviation. And remember, you've got to do this part first before you divide. So for Ryan's z-score, he scored 42. I'm just going to say z of Ryan is 42 minus, let's see, accounting. Don't let that 101 throw you off. That's just the class name. The mean was 35 and the standard deviation was 5.9. So I'm going to put that into my calculator either in two pieces or with parentheses around the numerator. And then I will do the same for Jake's z-score. So Jake's z-score, I'm waiting for my calculator to load up, scored 145 on Business 101 with a mean of 136. So they both did better than the mean. But the question is, who did relatively better based on the standard deviation and the mean of how their classes did? So who did better relative to their peers? And of course, these are just numbers I made up. So this has nothing to do with how well Ryan or Jake would actually do. So for this first one, I'll do 42 minus 35, which is 7, and then divide by 5.9. So I did it in 2 steps, so I didn't have to remember to put the parentheses. So we're going to round to 2 decimal places. So 1.19 for Ryan. So this one is 1.19. And then for Jake, we will do 145 minus 136. Which is 9, but it's a higher standard deviation. So 1.06. And so who did better? If you look at where a z-score falls on a curve, if you look at this being the mean, and if we talk about z-scores just being like this, then Ryan would be a little past 1, and Jake would be a little less past 1. So Ryan, in this case, did better. Okay, so I didn't have to draw the curve, but I just did it to sort of show you where they would land. Now for the next two, you will have to draw the curves. So this one about the Galactic Empire, I am going to draw the curve and I am going to add in all the numbers that I need. Okay, so the average is 467, and then standard deviation is 17, so I'll add 17. So 484. I want to double check that I did that right. 467 plus 17, and then plus another 17, 501. This one's 450, and then minus another 17, 433. Okay, and then it says, what is the minimum number of flights that the busiest 15%? So busiest pilots fly the more flights. So busiest 15% will be like here. This is 15% to the right. So remember, if you have an older calculator, you have to go to the left and you have to say it's 85%. So if you have a newer calculator, you can say normal CDF, and I'm going to run out of room, so I'll write it down here. Area, mean, standard deviation, and then you would use that right tail. If you have an older calculator, you would have to use the to the left. So you would say normal CDF, area to the left, mean, standard deviation. There is no place where it asks you left, right. But either way, you should get the same answer. So let's see. Normal CDF, we don't use normal PDF. And I used the wrong one. Oh my goodness. So when I go here and I look at this, I say, wait a minute, that doesn't seem right. It's supposed to be area. I'm being silly. It's not normal CDF. It's inverse norm. Mrs. Wilson is so silly. So even if you start to use the wrong one, if you know what is supposed to be there, then you can say, oh, wait, I'm using the wrong thing. So inverse norm, because I'm given a probability, my area, see this says tail, so I can go area, mean, standard deviation, and my tail will go to the right. And you'll see that when I do that, if I actually have my tail go to the left, which is what if it doesn't ask you whether you're to the right or left, then it's always to the left. We've got Beyonce functions all over the place here. That is going to give me the same answer. You can see that gives me the same answer no matter what, because I went to the right or to the left. Okay, so your answer would be, because it's a number of flights, your answer would then be 485 flights. The busiest 15% of pilots fly 485 flights or more.